All right, I think there's quite a few of you joining us now. So we're going to go ahead and get started with today's webinar. So good morning again, and thank you so much for joining our Research Radar Roundabout Roundup, hosted by the Minnesota Department of Transportation and the Minnesota Local Road Research Board. My name is Molly Ying, and I'll be your host for today. So joining us, we're excited to have our presenters, Derek Lohr, Mark Wagner, and Sam Budzina. So today's webinar is actually the 7th in our Research Radar series, sponsored by MnDOT's Office of Research and Innovation and the Local Road Research Board. Each month, we highlight different research projects focused on a common theme, and this month, it's all about roundabouts. So just to introduce our two organizations a little bit, MnDOT's Office of Research and Innovation manages over 185 research projects in progress that ranges from local initiatives to pooled fund projects with other states, and we comprise both basic and applied research. So we're basically here to help transportation practitioners determine whether new research is needed or if existing studies may solve your needs, recommend the best research methodology for your project, access local and national funding sources, and manage your project from start to finish. And one of our partners, the Local Road Research Board, is a city and county-run organization that sponsors research and educational initiatives that address local transportation needs. And with that, you can stay up to date with MnDOT and LRB by following us online and subscribing to our newsletters. We'll send you website and subscription links in a follow-up email after today's webinar. So for the fiscal year of 2025, we have funded 27 new academic research projects selected from a competitive pool of about 82 proposals. You can scan the QR code on your screen to view the full list of new projects. If you have subject matter expertise on any of these projects and you would like to serve on the technical advisory panel, please reach out to our office. And with that, before we get started, I'd like to read the Tennyson warning. This session will be recorded for those who cannot attend. If you have enabled your camera during the session, the recording may include your image, which is private data under the Minnesota Government Data Practices Act. You are not required to allow MnDOT to use your image, and there are no consequences for declining to do so. To opt out of the recording, please simply turn off your camera. Okay, and now moving on to the fun part, I'd like now to introduce our presenters for today. So first up, we have Derek Lohr presenting on traffic safety evaluation of pedestrians and bicyclists at roundabouts in Minnesota. Derek is a state traffic safety engineer for MnDOT in the Office of Traffic Engineering. His responsibilities include the development of the 2025 Strategic Highway Safety Plan, district and local county road safety plans, assisting in statewide traffic safety planning efforts, and providing technical assistance to state, county, and local agencies. Derek has a bachelor's degree in civil engineering from North Dakota State University and a master's in infrastructure engineering from the University of Minnesota. Up next, we have Mark Wagner presenting on evaluation of traffic safety for heavy commercial vehicles at roundabouts in Minnesota. Mark is the Assistant State Traffic Safety Engineer in MnDOT's Office of Traffic Engineering. He joined the office in 2020 after realizing that everything else is simply too boring. His passion for traffic safety means he will stop at nothing to improve safety, even if that means letting you know he thinks your ideas are a bit dull. As the resident bad boy of the Office of Traffic Engineering, Mark not only works to bring down the man, but also develops safety plans and evaluations and has a hand in all things traffic safety. And lastly, we have Sam Budzina presenting on Mini-Roundabout FAQs. Sam is a graduate of the University of Missouri and has been serving as the city traffic engineer for the city of Rochester since 2017. He is passionate about urban design, and he claims that 80% of his job is trying to figure out how to get people to slow down. He is also expecting his second child in less than 2 months. So early congratulations to Sam. Okay, And with that being said, I'd now like to pass it over to Derek to start off our presentations.
All right, thanks for that introduction. And Mark's and Sam's was pretty riveting. I'm gonna have to update my introduction. So, all right, I'm gonna go ahead and share my screen here. All right, is it correctly working?
Yes, it is.
All right. Well, thank you very much. All right. So as Melee said, my name is Derek Lure. I work in the Office of Traffic Engineering here, and today I'm going to talk about the traffic safety of pedestrians and bicyclists at roundabouts, and some of the evaluations that we have done and the work we've kind of looked at trying to figure out the answer to this question, because it is probably one of the most common questions we get when we're talking about roundabouts and suggesting roundabouts at locations is, how is this going to impact pedestrians and roundabouts? Can they use it? Can they use it safely? What does that look like? So it is one of the bigger questions we get. So we've looked at this a few different times in a few different ways, and I'm just going to go over some of the results of what we found and share that with you guys. So. All right, so pedestrians and bicycles safety at roundabouts. So you can see here we got a little cartoon going across the roundabout here, and a bicyclist as well. So just a little bit of history. This has been kind of a question that's been out there for a while. Without a significant number of roundabouts or a significant number of roundabouts in locations where people walk, this was kind of a hard question to answer with crash data alone. Back in 2012, there was a study that was conducted by the University of Minnesota that was purely observational. What they did was they took what's called a fisheye camera, and they placed this in the center of roundabouts at 2 different locations. And they really kind of focused on how are pedestrians and bicyclists using the roundabout, and how are drivers yielding to those people as they walk into the roundabout, as they walk across those legs, to see, are people yielding, are people slowing, are drivers slowing for those pedestrians. The starting location of crossing affects driving yielders. So that was one big finding, was they really found that where that pedestrian was starting as the vehicle was approaching was really important. Another thing they found was that as vehicles exited the roundabout, those yielding rates were actually lower than when drivers were entering the roundabout. But overall, what they found was there was actually really good compliance for drivers and to pedestrians in roundabouts. Probably much better than it was at typical through-stop intersections or even at signals sometimes. So what they found was fairly good compliance, and actually people who were drivers entering the roundabout were actually tending to go fairly slow, especially compared to other intersection approach types. A big NCHRP report came out a few years later where they did look at the data finally. They finally had enough sites to where they could get a good compilation of crash data. Overall, across the board, from a crash data perspective, roundabouts are knocking it out of the park. Roundabouts are probably one of the safest intersection control types we have, especially when we're looking at fatal and serious injury crash types. Typically, what we've seen with roundabouts in Minnesota as well, on another report that we've done, we saw 80 to 90% reduction in fatal and serious injury crashes at roundabouts compared to their before condition. What they found in this NCHRP report is that looking at it was hard to look at it before to after, and it was hard to look at this based on rates. But one thing they did look at was what's called kind of the crash mix. What are the crash types, and how do those compare to the totals? What they found was about 1.5% of the crashes at roundabouts were ped bike related. Now, that number on its own doesn't mean much to most people, right? What's a number by itself? You need to understand that in the grander scheme of things. But compared to signals, which most people kind of consider a signal as the gold standard, highest pedestrian control type measure, caveat, it isn't, that you can do for pedestrians. Traffic signals typically have about 2.5% to 3% of the crashes at a signal are pedestrian bike related. So right off the bat, though, roundabouts were looking much better for pedestrians and bicyclists than roundabouts. I'm sorry, roundabouts were looking much better than signals. One kind of anecdotal piece of information that was put out there that we thought was really interesting, and we still kind of try to highlight this when we can, but there was a transportation engineer in the Portland Bureau of Transportation. His name's Scott Batson. He looked at 7,000 roundabouts across the United States and 18 years worth of data across all those sites. And all they could find in all that data was 10 known fatalities of vulnerable road users. And from the anecdotal information we heard too, none of those actually occurred within a person walking across the roundabout. They were either people who were out on the crossing the circulating lanes where they probably shouldn't be, before the paths, or before the marked crosswalks. But 10, it can sound like a lot. 10 people is 10 people that did die. But when you compare that to the number of people who die at signals every year in the US, that number is astonishingly low. So a lot of the initial information that was kind of coming together was really showing that ped bikes at roundabouts was pretty significantly lower than what we would expect or what we'd see at other traffic control types. So that now comes to the Minnesota studies, the ones that were conducted back in this first one on the left here. Was one of the first studies we ever put out about roundabouts in Minnesota. This is one that I did back in 2017. We looked at 126 roundabouts in the state of Minnesota. We looked at the before-after data. What we saw overall was an 80% reduction in the fatal and serious injury crashes at Minnesota overall. We couldn't find any multi-vehicle fatal crashes. This report, though, we really kind of just looked at the vehicular crashes because that's really where we had the bulk of the data. And we did look at the ped bike stuff. We just didn't really highlight it. I'll take a little blame here. I kind of fat fingered a few of the numbers in there, and it didn't look real promising. But when we look back and vetted that information a little bit more, it looked promising. Shortly after that, we did an addendum, and this was the one where we looked at 100 more intersections, 100 more roundabouts, or we looked at 100 roundabouts in particular, along with 100 control sites, and looked at pedestrian bike crash rates and density alone. And what we found was from the before condition, or comparing those roundabouts to other traffic control types, we saw 64% lower crashes for pedestrians, both by density and by rate. So it was a pretty substantial reduction. Bicyclists, we didn't see quite the same reduction, but we still saw a healthy reduction. It was between 10 and 20%. If you kind of average it out, we had about a 16% reduction for bicyclists as well at roundabouts versus other traffic control types. So right off the bat, it looked really good. Those numbers were very promising. We really try to boast those numbers. It's one of the first things we share when people say, well, how do roundabouts compare to other traffic control types? Roundabouts work extraordinarily well for pedestrians and bicyclists. We did another study in 2022 about kind of user experiences at roundabouts, try to kind of gather some of the more, I'll say, that user experience, not so much quantitative, but more qualitative of how people feel about it. We looked at observational case studies. We looked at 8 different locations. We really focus on that pedestrian user by measuring, how do drivers behave towards pedestrians? What is that pedestrian behavior at the crossings? And then, what is that pedestrian infrastructure leading up to and at roundabouts, and how does that impact how people feel about it? One of the things that we kind of found in that study was, RFBs, the rapid rectangular flashing beacon at roundabouts, do increase yielding rates. And in-road signs, roadway signs satisfactorily work as well, not as well as that RFB. Another big finding, we found that people walking much prefer single lane roundabouts for walking across than multi-lane. That's probably somewhat intuitive. It's just fewer lanes, easier to navigate than some of those multi-lanes, which can be much more complex. And then this document did develop some guidance for practitioners for things that you should be thinking about when designing those pedestrian facilities at roundabouts. The other thing about the 2022 study, investigate the safety of roundabouts for pedestrians and bicyclists using more crash data and history. So we looked a little bit more at the crash data there. We did try to focus. Oh, I'm sorry. This is another study that we did in 2022. This is the one that Mark really headed up. But we kind of really wanted to look at, again, more data for ped bikes at roundabouts. We really focused on urbanized areas where we knew we'd have more pedestrians or more likely to have pedestrians. And then we also were able to update the data as well with this one. The other thing that we were able to do with this study is we added specific traffic controls, such as signals and stop controlled intersections, to see how do those two compare to each other. And we really try to get at the question, are roundabouts safer for vulnerable route users? So for those pedestrians and bicyclists, are roundabouts better than those other traffic control types? We tried to find all the roundabouts that were built before 2018, so we'd have a good, healthy after data set. Try to make sure the roundabouts were within incorporated city limits, so it truly was an urban area. We try to use what's called adjacent land use context. So we use Florida's DOT's context classification guide as the starting point. Minnesota was not that far along with their context classification guide, which we are now. It's now part of our facilities design guide. But we also tried to find roundabouts that were near schools with walking and trail connections. We tried to find sites that were near popular walking and biking routes. And, quite honestly, we did use a selection bias of sites with a higher propensity of vulnerable road users. We wanted to find the sites that were more likely to have pedestrians walking at them. Even though it maybe exposed us to more crashes or possibly more crash data, it was something that we really wanted to emphasize, that we were specifically looking at sites that were most likely to have pedestrians and bicyclists using those sites. By the time we got through all this, we had about 95 sites for 95 roundabouts that we could use for evaluation. Here's that context guide if anyone's interested. Basically, it's just a way to make sure that we're correctly identifying the land use. So we try to focus kind of more on the right side of the graph here. Areas that were suburban, urban, developed, that we could really base it. Sites where people are likely to be walking. Signals, we kind of did the same thing. We tried to pick signals that would have similar flavor, if you will, that were more urbanized, that were more likely to have people walking, and similar with urban stop-controlled intersections. We wanted to make sure the site you built a roundabout and the sites we selected for evaluation, the signals and the through stops looked very similar to those, so that we had similar traffic volumes, we had similar land use context, similar sites, so that we were really trying to make sure that we're comparing everything equally. We pulled the crash data all the way back to 1998. We really wanted to get as much data as we could for that before situation. We started to look at the other things that we looked at were entering volumes, the crashes, both motorized and non-motorized. We tried to get as much site characteristic data as we could, construction year, number of circulating lanes, types of approach lanes, the previous traffic control type, and then try to figure out a way to do what's called latent demand for vulnerable road users. So are these sites that are likely to have vulnerable road users based on other characteristics, kind of what's known as latent demand. One of the sites we did have to throw out after we had selected, and that was one of the roundabouts that was on near the casino in Mystic Lake. And that site was removed mostly because data was a little bit lacking, but then also they had removed that for a higher capacity type of system there to be able to get more people into the casino. So here's just kind of an example of one of the sites that we looked at. Here's Minnehaha and Godfrey Parkway. This is actually probably one of the oldest roundabouts in Minnesota. This is also probably one of the highest ones where we have pedestrian bikes. There's a lot of trails here. If you've ever been to Minnehaha Park in the summer, there are a lot of people walking, using the trails, enjoying this area, and they're frequently walking through this intersection. So, yep, roundabout, park, people walking, a lot of transit. Military or the veteran center is pretty close to here as well too. So there's a lot of people who go either live or are covering at these facilities and they go use the park to walk around. So a lot of natural land. I won't go too much into that just to keep things moving. So we looked at before, after. We looked at a comparison with traffic signals, and we looked at a comparison with urban through stops. So we tried to make sure that we're kind of comparing all those things equally, and then also the same number of years, so that we're not just looking at before, after. We're looking at sites that are roundabouts, sites that are signals, sites that are through stop. And what we found was from the before to the after, we saw a pretty good reduction for pedestrians and bicyclists at those roundabout sites versus their before condition. Once again, we saw this 50 to 60% reduction across the board in injury type crashes. We did see a rise in property damage crashes. This is one of those flukes of crash data that's really hard to explain. Pedestrian data. This was just overall data. If we look at the ped bike data, a little bit more mixed, but those KAs, we still saw that 40 to 50% reduction. Those densities, those less severe injuries, we saw not quite the same reduction. With the Ks and the As, we're just kind of suffering from small numbers. We don't have a huge number to work with, but we did see a pretty good reduction overall. Property damage crashes, this is where I was saying this is one of those flukes of crash data. I don't know how you necessarily have a property damage crash with a pedestrian, or if they're just recorded more after the fact, but that was one of those things we saw a rise in. I don't know if that's necessarily alarming, but really this 40% reduction in fatal and serious injury crashes is probably the number that we want to when we look at statistical significance of that before after fatal and serious injury crashes, we did see a statistically significant reduction. It's kind of right on the value of we saw a change in the crash density that was significant. The change in the crash rate was not as significant. That's be a whole host of reasons for that, but and then the other one that we saw was the injury crashes. We did see a statistically significant reduction in that. That was a p-value that's about as high as you're going to get, or in this case, as low as you're going to get, which is what you want. But then as far as the rest of the crashes, we were kind of bordering on statistical insignificance, which is a little frustrating. We did want to see statistical significance, but we did not see that with those ped bike KA crashes. Even though we saw a reduction, we're just working with numbers that are too small at this point. This is probably one of those things where we are working on a roundabout study update, and we are hoping that once we have more we'll have more sites, more years, more data, we'll be able to flesh out that statistical significance. Overall, compared to traffic signals, roundabouts are much lower. The way to read these charts, the spot that's highlighted green is the number that's the lowest. So if we look at roundabouts by crash sites per year, they're about half that of a signal. And you can see that for Ks and As, it's probably about 80% lower for pedestrians and bicyclists at roundabouts than it is at traffic signals. So once again, for roundabouts, they're outperforming signals by not just a little bit, but by a lot. Once again, can kind of go through all these numbers. One thing that kind of competed really well to roundabouts as far as ped bikes goes is actually the all-way stop. The all-way stop is probably one of the underappreciated traffic safety control types out there. It actually has a pretty good record, and we don't have a ton of sites, but when we look at those sites, they typically have very few crashes, and they have even fewer ped bike crashes. And even when we control for things like volume and density, all-way stops usually do pretty well. So what does all this mean? This is my last slide. So the way I always kind of say this is if I had 100 roundabouts for 10 years, what could we expect for crashes? If we had 100 roundabouts for 10 years, at those 100 sites over this 10 years, we could expect about 10 pedestrian crashes and about 30 bicycle crashes using our crash rates. If we use density, you can see we get about 6 pedestrian crashes and we get about 18 bike crashes. So, if you kind of split the baby, expect about 8 pedestrian crashes and about, 25 bicycle crashes at roundabouts at 100 sites over 10 years. But if you compare that to those other types of sites we have, like signals and some of those through stop type intersections, we'd have significantly more. You'd probably have about 3 times as many pedestrian crashes at those sites, and for bicyclists you probably have probably about 20% more. So this is one of the hard things with crash data. You need a lot of sites, you need a lot of years, and you're still dealing with small numbers. So it's going to be hard to tell for a long time if it's are we getting a blip in the radar, or are we really seeing something significant? Everything we've seen so far, all the crash data we've seen, when we've looked at this time and time again, we see significantly that pedestrians and bicyclists have much lower crash incidents at roundabouts than at other traffic control types. That's what I just said. This was published in 2023. The roundabout I just went through, Mark, who's going to talk next, was kind of the chief author behind that one. And like I said, we're working on kind of a big roundabout evaluation right now. We're calling it our all-encompassing roundabout study for 2025 here. We're getting as much data. We're going to try to answer as many questions about roundabouts as we can with this study. Other things that are going on, right now there's an evaluation of roundabout crash rates, effectiveness, and driver education that the local road research board is looking at right now. They're starting that project up right now. And then the MnDOT research office is also working on a study called Improving Safety for People Walking and Biking at Roundabouts. So that's another one that's going on right now. And with that, I am done. Thank you, and I will turn it over to turn it back over to Mark.
Yes.
All right. Thank you.
Taking over from here. All right. So I'm going to now shift a little bit here. We're still going to talk about roundabouts, but we're going to start with heavy trucks now. So this evaluation was about overall heavy commercial vehicle safety at roundabouts in Minnesota, with some more specific drivers that I'll get to as I get deeper into the presentation. If you're wondering, this is a picture I took from a roundabout down in Hastings, I can verify definitely that I was not driving and using my camera at the same time. I promise. So just to back up a little bit, we now have an officially signed 2025 to 2029 Strategic Highway Safety Plan. In that, it identified about 3% of fatal and serious injury crashes that involve commercial vehicles. So that puts heavy commercial vehicles or commercial vehicles in the connected focus area alongside things like older and younger drivers or work zones. So it's not a huge portion of the overall severe crashes that we see when we talk about focus areas, but they are, I guess, intertwined pretty well into those crashes. So there's a good chance that a truck involving fatal involving a heavy commercial vehicle is also going to touch on speed or inattention or intersections or roadway departure and things like that. So what it means is that making the roadways safer for heavy commercial vehicles and preventing those severe crashes is also a good way to make progress on those bigger focus areas. In the Strategic Highway Safety Plan, we've got these tactics and strategies. So the strategy is like the what. So in this case, it's designing and planning and maintaining roads for commercial vehicle safety. The tactic is how are we going to do that? And then key tactics, which have obviously the blue key next to them, are ones that are either like very timely or especially important. So in this case, in 2.1, roundabouts aren't listed, but I think I'll show with this presentation that roundabouts are another great way to use roadway and geometric features to reduce those severe crashes involving commercial vehicles. So this evaluation was driven a lot by stakeholder concerns, especially in greater Minnesota. We would hear from our districts occasionally that stakeholders are very concerned about rollovers involving trucks at roundabouts. It's just that trucks have to go onto that apron, and that can cause load shifting, which was a big concern about then that could cause the truck to roll over. But then, since we were grabbing a bunch of sites and a bunch of crash data, we thought, let's take a look at the overall safety as well and not just look specifically at rollovers. And then ultimately to help address this question for the public of whether roundabouts really are safer for heavy commercial vehicles and are they more prone to rollovers in roundabouts. So I used TRID to look at some national research first. And this was really looking at what influences rollovers at roundabouts. So the three big categories that stood out were geometry, vehicle factors, and driver behavior. So geometry, the slope of the road, the circulating roadway, the apron design, and then whether it was single lane or multi-lane had an effect, small or big, on whether or not there was a greater risk for rollovers. If you think about a multi-lane circulating roadway in a roundabout allows a truck to use both lanes to navigate through instead of going onto the apron. So that's a situation where single lane roundabouts are great. Could single lane roundabouts be a contributor to rollovers? In some situations, it's possible. Configuration. So single unit trucks, the box trucks that you see, were the most stable. And those longer ones, like the 67-foot trailers, or you'll see like a UPS or a FedEx with two 40-foot trailers. Those were the least stable configurations. Ironically, fully loaded trucks, so that's not ironic. Fully loaded trucks had a higher rollover risk. What's funny is empty trucks were actually less stable than partially loaded ones, which doesn't make a ton of sense to me. This is just what the research said. And then driver behavior. I mean, obvious things like if you go into the circulating roadway too fast, that increases your rollover risk. Education for optimal speeds through roundabouts or effects of loading could also be a good way to address those rollovers in roundabouts. This roundabout, we picked 107 for evaluation, fully operational by 2017, so we could get 5 good years of crash data to work with. We wanted sites that had recorded heavy commercial AADT. unless there was a specific land use nearby that indicated heavy truck traffic. So if there was no heavy commercial AADT for a roundabout, but there was a Walmart distribution center in the northwest quadrant of the roundabout or very close by, that's an indication that there's going to be plenty of truck traffic through that intersection. So we focused on the bigger roadway systems like the trunk highways, the county systems, and the MSAS or Minnesota State Aid Street system. And then ones that were not located in primarily residential areas. For obvious reasons, trucks generally don't travel through areas like that. Same thing with the signal control sites. So, we use a signal control comparison group just because when you go to the public and you talk about a roundabout, I think the next thing that comes up too is, well, a signal would be better here because of the rollover risk and because, truckers are more familiar with it, et cetera, et cetera. So we wanted to see how roundabouts compare to signals as involving heavy commercial vehicles. Exact same criteria for selection here for the traffic signal sites as the roundabouts. The analysis here, we didn't do a before after in this case. This was purely a comparison one. So we grabbed 2017 through 2022 crash data. We looked at the crash rate both for all vehicles entering and then for those heavy vehicles that were entering the intersection. And then we also looked at some of the most common characteristics in the crash reports that are associated with heavy commercial crashes. A quick overview of the data we had here. So, total entering volume. Let me just grab my laser pointer here. We looked at, we added up the total entering volume for all vehicles, heavy commercial vehicles, total crashes. We just looked at some general crash rates here. So, signals slightly higher, heavy commercial crash rate, slightly lower total crash rate than roundabouts, which this isn't surprising. Some cases when we introduce a roundabout, we actually see more overall crashes, but the severity of those crashes goes way down. We see almost none of those fatal or serious injury crashes, even if we see a lot more of the property damage or fender bender variety. The results of the comparison. So if you look at the percentages, it tells one story. If you look at the numbers, it tells a different story. So it's like Derek said, with the peds and bikes at roundabouts evaluation, we're dealing with a lot of very small numbers here. There's just not a ton of heavy commercial crashes out there compared to the broader picture of crashes on in our state. I think a couple of the comparisons to look at here are these minor injury crashes. So we did see a lot less of these relatively at roundabouts than at traffic signals, and the rates are lower there. And I think, it's kind of the same story for roundabouts. We tend to see less overall of these severe crashes. We start to see a shift to some of those lower injury crashes. And then PDO, surprisingly, less PDO crashes for semis at roundabouts. Who would have thought? Let's see this one. Oh yeah, okay, sorry, I had a transition in there and I think I just forgot to delete it. So the other part of this analysis was, do heavy vehicle rollover crashes occur at roundabouts more often than signals? So in the set of roundabouts we had, the short answer is yes. So there were 15 rollovers at roundabout sites, which is about 10% of the heavy commercial vehicle crashes in the data set. A fatal, 3 minor injury crashes, and then 11 property damage crashes. And only one of these were at traffic signal sites. So 1 compared to 15. That's a pretty, I think, stark comparison there. The thing about these 15 rollovers, this fatal crash was later confirmed to be a medical event first. So it's not to say that if it was not a roundabout, it would have been a fatal, but it's harder to say with certainty that the roundabout was what caused the fatal crash there. And about half of these 15 were at 2 of what I'll call our problem child sites. Highway 7 and CASA 10 down in Carver County, I think it's Carver County, is one of the older roundabouts on the trunk highway system. The curb design on the truck apron is a little different than what we use now. And it's same thing with this one down in Worthington. It's a heavy truck area. I think there is a food processing plant near there. And it's just got some of those older designs that contribute to rollovers. So this actually motivated me to look a little deeper into it, because what we heard then from our geometric standards unit was that in 2018, they changed a lot of the roundabout design standards around curve and apron design to address these concerns about load shifting and rollovers at roundabouts. And when we look at crash data from another set, so we just looked at, we took out the roundabouts that we had in the evaluation. We just wanted to look at a totally different set of roundabouts to see if the frequency of rollover crashes changed at all with newer roundabouts. So in these ones that were constructed between 2018 and 2023, the percent of rollovers goes down to about 3%. And the injury shift, there's no fatal or serious injury crashes. So we have 1 minor injury and 7 property damage crashes. So this is by no means a hard statistical analysis, but it does suggest that when those changes were made to roundabout design details, it did really help reduce rollover crashes at roundabouts. And then real quick here, I'll just browse through some of these crash factors. So the highlighted ones are ones I thought were kind of quirky or interesting or worth pointing out. So basic type is just the officer at the scene preparing the crash report, records this. I thought it was funny that 13% of them were recorded as angle crashes. And that's because technically you're not supposed, you can't have an angle crash at a roundabout. It's impossible for 2 vehicles to meet at a 90-degree angle at a roundabout. Effectively, some people could get creative. That's not what we're here to talk about. But, still it's, 13% of those crashes were reported as an angle, even if it's not technically that full T-bone crash that we really mean when we talk about angle crashes. Most harmful event. So this is where, we did see roundabouts again jump out. 9% of the ones reported in roundabouts were of the heavy commercial crashes were overturns or rollovers. I think that just kind of reiterates what I showed earlier. In configuration, when we look at overall crashes, this is not just rollovers. Trucks pulling trailers had kind of a weird difference here between roundabouts and signals. So they were a lot more frequent in roundabouts, a truck pulling a trailer. So I think this could mean like a work truck, like a landscaping crew pulling a trailer, somebody pulling a boat, someone someone pulling an RV even. It could be that. I don't know exactly what goes into this category for every single situation, but it is interesting that at roundabouts, these were more frequent crashes. Cargo body type, flatbed trucks, for some reason, way more frequent at roundabouts. I don't know. Again, probably just some kind of quirk of the data here based on the sites we selected, but it did rise a lot higher than traffic signals in this evaluation. And then another kind of funny one based on how an officer would report this, the pre-crash vehicle maneuver was at a roundabout considered negotiating a curve. There's no curve at a roundabout really. These should really be in that turning left or turning right category, because that's really the movement you're making at a roundabout. But I think some of it is just there's that intuitive thought that if they're going around the center island, like this truck you see in the corner, it still might be something some people consider negotiating a curve in a way. So overall, what could we draw from this evaluation? Just based on the limited numbers we have, fatal and serious injury crashes at roundabouts, you see about a 50% reduction or 50% fewer compared to signals. And that's just based on this study. We had those lower rates at roundabouts of the minor and suspected injury at the B and C crashes. And then, I think we answered in a way the question of whether or not those rollovers are more frequent. They were, based on older design standards. But now that GDSU has changed some of those standards, we've really seen that rollover effect kind of go away. It's down to 3%, which is, about, one rollover in all the commercial vehicle crashes at signals was about 1%. So 1% at signals versus 3% at roundabouts. Those are very close percentages now. So that effect is kind of disappearing as we put more and more roundabouts with newer design standards in. And then I think some of those findings I pointed out in the previous charts really just indicate that we just need to do a little more effort in making sure officers are clear about, or whoever's reporting the crash is really clear about what goes into each category, and just making sure that those details and that guidance is clear. This one was published about a year ago now, and the link is both active in this presentation, but you could also find it on the MnDOT research website. And with that, I'll leave my contact information up for just like 10 seconds here, and then I will stop sharing and I'll hand it over to Sam.
Yeah, great. Thank you, Mark. I'll just go ahead and get started. On my slides up quick. So I'm here to talk about mini roundabouts. There's an LRRB project on mini roundabouts. So I serve on the technical advisory panel, so as a TAP member. So more about myself, I started my career down in Missouri, the city of Columbia, Missouri. And so I was around when they built their first mini roundabout, and I got to see the opening of that. And then I moved up here to Rochester, and they were in the middle of constructing their first mini roundabout. And the design was a little bit different, so I got to see, how the driver behavior at those two different designs, as well as the public perception of it. In Rochester since then, we've built 2 more mini roundabouts, and over the next 5 years here, we are going to build about 15 more of them. So we have a lot coming. So safe to say, as a city traffic engineer, I like mini roundabouts. This is the report that again released June 2024. It's a list of frequently asked questions, but it also gets into lessons learned. What is a mini roundabout? Why is it different from a standard one? Why would you want to use it? It's a really great resource for anybody that wants to learn more about them, or if you're thinking of building one in your community or within your authority, roadway authority district. This is a great resource to look into. So, we surveyed local agencies around the state, developed this list, and then at the end, there's also a database of mini roundabouts around the state. And it's listed by, different design elements of the roundabouts. So if you're looking at one and within a certain context, and you can look through the list and see which one's kind of similar, and then every single one of those has a contact person at that agency that they've agreed to answer questions about it if anybody has them. So there's just a ton of resources in here. These were the TAP members, like I said, that I'm particularly interested in, so I jumped at the opportunity to participate. And just a quick plug for any LRRB project. If you have the expertise, I'd encourage you to sign up for the TAP. These are the questions. I'm not going to stay on this slide too long because we're going to go through the questions. So the first off is, what is the difference between a mini roundabout and a standard roundabout and compact? Just this week I was emailing somebody and they called it a compact, and I was like, hold on, I thought we were talking about a mini roundabout. But the biggest difference is here that the central and splitter islands are going to be all traversable. With a compact roundabout, they're a little bit bigger, maybe you can call it a medium-sized roundabout, but they don't always have traversable splitter islands. They're still going to have the traversable central island. Some of the larger compacts might even have something small in the center that's not traversable, but it's going to be mostly traversable island, which is very similar. I mean, it's basically a big truck apron, right, that you would have on your standard single lane roundabouts. But those are the differences. They're just smaller and traversable. Compact, a little bit bigger, a little less traversable. So why would you even want a mini roundabout? Basically, they're a lot smaller. They're really good at handling low volumes of traffic. I really like them as alternatives to all-way stops. I'd much rather see a mini roundabout than an all-way stop, especially in some of our local neighborhoods. They're great traffic calming devices. You know, the new MUTCD, which Minnesota is getting ready to adopt, our own version of it. You know, it very explicitly states stop signs shall not be used as traffic calming devices. Mini roundabouts are really good at traffic calming. Typical design features, like I said, they are smaller, they are traversable. Yeah, no signs in the center island. Again, if you put a sign there, then it's not traversable anymore. So you really got more of a compact. They do tend to have a single stage pedestrian crossing. That's going to be another big difference. You can have smaller splitter islands that aren't always wide enough to technically be a pedestrian refuge. Plus they're traversable. So if you model your truck turning movements and they need to traverse over the pedestrian crossing area, that can be okay, but you should really make sure you're using that or designing it as a single stage pedestrian crossing so people aren't standing there while large vehicles are navigating through there. But in that situation, they should be yielding anyway because it is a marked crosswalk. So yeah, how do you decide what type of roundabout to pick? Again, these are great for alternatives to all-way stops. If you meet signal warrants and you have more space, then a standard roundabout might be better. Obviously, these are not going to be big enough for if you have a lot of large vehicles, especially where they're making U-turns. With respect to safety, Derek and Mark both talked about this a little bit, but they are significantly more safe than all-way stops. So MnDOT has this report that Derek talked about a little bit. I don't think they specifically talk about mini roundabouts in there. It's more just roundabouts in general. On the bottom there, FHWA does specifically talk about mini roundabouts, 39% total crash reduction, which is pretty significant. How do you accommodate those large trucks and farming equipment? They can drive right over the top. Like I said, it's basically a truck apron. That is one of the complaints that I've gotten a lot at here in town is, oh, people are just driving right over the middle. Well, it's designed to be driven over. You could actually just paint the center island. It doesn't have to be raised at all. In my experience, I like a 3-inch central island and 4-inch splitter islands to really discourage those drivers from driving over the center of it if they don't have to. A truck could still easily do that, but you really want to try to encourage those smaller cars to stay around the circulatory part of the roadway. And again, don't place signs in the middle because you need that space for turning movements. As far as how do you encourage those small vehicles to drive around like they would at a full-size roundabout, again, like I said, you really want to get that island raised up. That's going to provide your most traffic calming benefits as well. What signing is necessary? So on the left there is the figure from the MUTCD that shows the mini roundabout. It's just the yield sign with the circulatory roadway sign. There's not much to it. One thing this does not show is a street name sign for a mini roundabout, which has been a little bit of a struggle for us, but what we've been doing is just putting, we would sign it just like we would any four-legged intersection and just put a sign assembly up in one quadrant. Because again, it's not that far across. You can still see it. And way less signs than your standard roundabout on the right there. So yeah, lessons learned. This being on this TAP, I will say this is one of the more active TAPs that I've been a part of. Lots of representation from MnDOT and counties and cities and all those different perspectives. And as we're answering these questions as a group, really everybody had their own opinions, and it was a really good conversation to be part of. So a lot of the questions here are very context dependent. I think my lesson learned from even being part of that conversation is if you're building one of these in a back in a residential neighborhood, I probably wouldn't just copy one that MnDOT built on their trunk highway system. I'd make it a little bit more context appropriate, but yeah, do what you can to slow speeds. Try to introduce some curvature if you can. Again, the smaller you can get them, be more appropriate for those local residential streets. And then again, about curb height, it's okay to just paint a yellow circle out there. You just don't get as much of the traffic calming benefit from that. People can just fly through there. They don't, that's one of the questions I get asked a lot is, can you just drive straight through? And it's like, well, yes, you can, but the ones we have those raised central islands, so you can do it, but it's pretty bumpy. You can go full speed over any speed hump too, but you're going to feel it. But if you want to do it just as a pilot project, feel free to paint it and then decide if you want to move into invest in something more expensive. Again, with signs, if those in-street pedestrian crossing paddles, they're great to put in a standard roundabout in the splitter island. You really need to check your turning movements before you put it in a mini roundabout, because you basically, as soon as you put that sign up, it becomes a compact roundabout. You don't have a traversable splitter island anymore. So you really want to think about that before you start putting signs up. And then education outreach, they are different than a standard roundabout, and it is okay to drive over the central island. Again, that's one of the biggest complaints we get is people are driving over the central island. And I just have to remind people that's not illegal. It's designed to be driven over. It's perfectly fine. But you want to try to get into your design, encouraging people to go around the circle. And then in the report, there's also a section about winter maintenance. I remember that first one here in Rochester. I was new to the city, and our maintenance manager at the time was pretty upset that we had just built this thing, and I thought he was going to flip over a table. He was like, "How are we supposed to plow this?" And so, anyways, there's a lesson learned in here about typically what people have been doing. Just plow the circulatory roadway. The middle part is basically just a truck apron. Those larger vehicles can make it through a couple of inches of snow. If you get a significant snowfall or several smaller ones back to back, you might want to eventually come back and plow out the central circle, but it's probably okay to leave it most of the time. And there's more resources in there. Again, more design guidance. The NCHRP reports are great, as well as the MnDOT facility design guide. There's some general stuff in there and some videos. And again, our database that is in the report, it lists the latitude and longitude if you want to look that up on Google Maps. Other design elements specific to each roundabout, or this is from the survey that we sent out to everybody, and the contact information for each one. If you have a question about a specific location, feel free to reach out to these people. They've agreed to be contacted and answer questions about them. And with that, there's my contact information if there's any follow-up info questions. Thanks.
Awesome. Thank you so much to Derek, Mark, and Sam for presenting great info on roundabouts. I think the overall consensus is that roundabouts are a great traffic safety feature. So looking at the time, we do have a few minutes for questions. So you have a question, feel free to drop them down in the chat, or you can also raise your hand to ask them verbally. Just looking at the chat here, I see that kind of Heidi and Lauren had same questions. Derek, I don't know if you want to expand on kind of if there was split data on like bike crashes at roundabouts using crosswalks versus using the driving lane.
Yeah, so when we did the initial analysis, we just kept it all lumped together just as bicyclists. But as Mark kind of indicated, we did go, I did, went in and actually reviewed all of those all those bicycle crashes, because there were few enough to where we could actually just do that, read the actual narratives. If I recall correctly, and this was a while ago, but what I recall was most of those crashes were bicyclists that were essentially entering the roundabout similar to how a vehicle would. They would actually use the circulating island itself to go into the roundabout and go around. That's just what I recall. I think it was a small difference between that number and the ones who were walking across. I don't even know if I can remember any that were specifically people essentially treating the roundabout as a pedestrian would. But we're talking small numbers here. I do remember having the thought that I guess if I was on a bicycle riding towards a roundabout, I would probably get off, dismount, walk through the roundabout, and get back on my bike. Was that the crash data was that big of a difference? But I think once again we were dealing with fairly small numbers to where it'd probably be hard to show anything significant other than the anecdotal story I just told you. So.
Thanks, Eric. All right, looks like we have a question from Brian. What is the comparable installation and maintenance costs for traffic signal intersections and roundabouts in the same area?
I can take a very high level swing at that. Of course, there's going to be 1,000 different variables that are going to influence this answer. But right now, for kind of ballpark reasons, MnDOT, we are estimating, we probably throw the number for a roundabout, and this is reconstructing an existing intersection. You're probably talking $2 to $3 million for a roundabout. If you are in areas that are more complex or have additional challenges, you might be in the $4 million plus range for a roundabout. If you're looking at a traffic signal for the hardware alone now, so let's say everything is in place as far as the pavement and the curbing goes, installing a MnDOT approved signal now is probably somewhere between $800,000 and $900,000 to just put in that signal system. If you are talking about reconfiguring an entire intersection for a signal, you are probably in a similar range to the roundabout, probably in that $2 to $3 million by the time you get everything all laid out. Once again, a lot of variability on these things. As far as maintenance goes, the roundabouts, the maintenance is fairly similar to most intersections. Lighting is fairly similar. I think the only other cost I can add for the cost of a signal for the power and the maintenance, I think we did a study a few years ago and we averaged, I want to say the number was about $5,000 per year to do the service maintenance and paying for the power costs at a traffic signal. So those are some really rough numbers. Please never hold me to any of those if you're proposing a project, but it can be very highly variable, but those are some of the ballpark numbers. Hopefully that answers the question.
Good. Yeah.
I know the question is about maintenance, but you gave the construction cost for roundabouts. I will say for mini roundabouts, if you spend $3 million on it, I think you're doing something wrong. I'd probably put that closer to maybe $300,000, right?
Yeah.
They're great because they fit in small spaces. A lot of times you can use your existing curb lines and work within that, but you shouldn't be having to buy a lot of right of way and things like that.
Yeah, there is a national NCHRP project right now that's looking at mini roundabouts, and yeah, I think you're right, Sam. I mean, some of these states now are doing them for $200,000 to $500,000 to install a mini roundabout. And once again, a lot of variable, a lot of different things can go into that, but yeah, they can be done fairly cheap. So,
All right, thank you both. Next question we have from Jeremy. What factors determine the actual size of the center island? Some are lower and can actually see oncoming traffic versus entering blind other than checking on to your left. So any thoughts on that?
I can take a quick shot at this one. It almost always ends up being I'm going to misuse these terms. It's either the design or the control vehicle. But it's usually what type of semi is going to go through there, and do you need to accommodate a larger vehicle like something hauling a wind turbine or a logging truck? Those tend to dictate, at least on the trunk highway system, what size the roundabout will be. And that's why a lot of ours end up being in that 145 to 190 degree ICD range, is just because we have to accommodate those large semis, and especially in some of our outstate districts, wind turbines and mining equipment can tend to be tougher to accommodate, so we have to get into those bigger radii. Can't speak for Sam or other cities, but they might get to do things a little smaller.
I feel like the question may have been about the height of the central island as well.
Oh, okay. Okay, that's fair.
But which I can try to answer too. I mean, I think the higher it is, the more you're obscuring people's vision, and they're entering an area that they would be uncomfortable driving high speed. So if you're intentionally obscuring their vision, right, you're introducing that traffic calming element. For a mini roundabout, obviously you can't get it up high enough to obscure anyone's vision, but you do want to think about how much of a traffic calming effect do you want to have.
Awesome. Thank you. And I guess for our last question, I know, Derek, you typed in an answer. Did the bike ped data look at any differences between single and multi-lane roundabouts?
Yeah, I might have to rely on Mark a little bit here too, but I believe when we looked at those numbers, we actually saw a somewhat larger reduction at the multi-lane roundabouts. But then again, as I stated in the chat pod too, we are suffering from, and maybe this is a great sign too, right? We are just dealing with really small numbers here. When we're talking, I'll throw out a number. 20 pedestrian crashes, and 11 of them were at signal lanes and 9 of them were at multi-lanes. And you look at the reductions overall, the multi-lane might have been a little bit more of a reduction, or flip that, whatever it is. We're just dealing with really small numbers where it's hard to discern. Is it something real, or are we just seeing good reductions overall, and it just happens because of we're dealing with whole numbers of crashes. That's what we're suffering from. It's it's one of the double-edged trouble with crash data, especially fatal and serious injury crashes. Sometimes we just don't have a lot of numbers to work with. Now that's usually a good thing. We don't want more fatal and serious injury crashes, so we can do more data analysis on fatal and serious injury crashes. But we just have to be aware of that when we're going into a thing that sometimes we're dealing with small numbers, and that can kind of skew the analysis one way or the other. So you just got to take it with a grain of salt. So.
Awesome. Thank you, Derek. And with that, we are at time. So I just want to thank our presenters again for providing such valuable information on roundabouts. Thank you all attendees for joining us today. We hope that you'll join us for our future Research Radar webinars. And after this, you will receive a follow-up email with all the resources that we shared today. If you have any more specific questions, feel free to reach out to our presenters. And with that, that concludes today's webinar. So thank you all so much.